solve it the next LeetCode program. 503. Next greater element 2. Given a circular integer array nums, next greater element of the nums dot length 1 minus 1 is return the 0. Return the next greater element of every element in the nums. The next greater element of a number x is the first greater number of the traversing order next in the array, which means you could search the circular to the find the next greater number. If it does not return the minus 1 for the its. Okay, firstly understand what the question said. It said that there is a array given that in which we have to the find out next greater element of the every element that is the present in the array. Okay, that's okay. We write down the what is the given is array. How what we have to the find out. Find the next greater element of array every each element of array. See, we have to the find out the next greater element of every element of array. Okay, how we are going to the find out? Let's understand. Let's take this example and understand with here. Okay, this is the array. We take we okay, we are going to the make the another array, and that name is the result, and start traversing. Here we are going to the start traversing from the index 0 when result. Okay, see, we okay, we are going to the erase these things nums, and what is the written? Let's start. Nums is given at 1. Let's see that 1 2 3 1 2 3, after that 4, and after 3. Okay, let's erase also this one. Okay, and take it here. We are going to the make it the result, and we store it. Okay, okay, let's we are standing at the indexing 0, and here is the what is the value of the index 1. The value is the 1, and for we are start reversing of the next indexing. After that we see that 2 3 4 3, which is all the greater than, but we are going to the pick the greater element that is the nearest to the 1, and of course the 2 is the nearest. Of course 2 is the nearest, so we pick it. And after when we find out the next greater element of the 1, we are going to the we are increase the value of the indexing, and we see that 2. And what will be the greatest value? The greatest value of the 3 4, but So we are going to the pick the one, that is the nearest of the it. And what is the nearest value? 3. Okay. See, in similar way, we are again we are increase the value of the I 1, and we are standing at the indexing 2, and that value is the become the 3 at this point of the times. And we are going to the go through the right side and see what will be the greatest value, next greater, and we see that the 4. So we pick it the 4. After that we are standing at the 4 and see that what will be the greatest element in it. 3, and 3 not greater than. After that, see, this is the Satkuda array. So we start from the initially, that 1 is the greater than 4, no. Then we go one step ahead and see 2. Again 2 is not greater than 3, no. 3 is also not greater than, and we finally we come at the same indexing where we are standing, but we can't consider it the 4. So that at this indexing we are going to the store -1. Again we pick, again we increase the indexing 3, and see, after that there is no element. So we are going to start it from the indexing 0, and go through the value we have, as we pick the 3, before 1 is -1 indexing. So this we are going to the search it from this point from this indexing to this indexing, and one by one see 1 is the greater than 3, no. After that we go through the 2. 2 is the greater than, no. 3, no. We are going to the see the 4 is the greater than. So in here we are going to the store it the 4, and this is the answer. And okay, in this, okay, what is the approach of the 8? Simply, the approach is just simple. We are going to the traverse the element of every element of the array one by one, and find out the greatest element. As soon as we are going to the find out, we are going to the store in the array of the result. And if we are not going to the find out, then at that point of the times we are going to the store -1. See, when I pick the one element, we are going to the traversing at it's we are going to the traverse from the indexing I 1 equal to at the end of the array. When we pick the 2, we are going to the search the next greater element from the next indexing I equal to 2, or 2 I equal to array dot length. And again, before it here we are going to the also search it. When we are not going to find out the next greater element in the right side, we are again go through the left side also. So we are for solving this approach, we are going to the take the 2 array, not only the one array. They nested. Okay. So now here we come to the solve it. Here let I equal to 0, and I start from the n. I start from the n, and I plus plus. Okay. Here const n equal to nums dot length. Okay, this one, this, and we take the another array, that is the result, that is the also array. And this array start from the indexing 0. One by one we are going to the increase it. Okay. Here again inside we are going to the take it another. Here I start count start from the 1, and count should be the n, where n is a here the count is the n equal to what? N equal to we are going to the search it the number of the total number of the elements, not here n denotes the array dot length. Here total number of the elements. We are going to the search it, and we take the okay these things. Okay, so we are going to the find out the current index, current current index, and how we are going to the find out the current index. Current index we are going to the find out is count I plus count and divided by the in here. We are going to the check it condition if nums dot nums dot okay nums dot I. If how we are going to the find it, if we say that if the current index is the greater than the element we are going to the pick it, then we are going to the put it the result k, and that is the what, that is a nums dot current index, and after that k increase it, and we are going to the break it. We are not going to the search it the further, and what if we are not what if we are not going to the find it at that point of okay, let's take the a variable, and initially that name is the found false. Okay, when we are going to the find it, when we are find it at that time we are going to the assign the true, and after that okay, if we are not going to the find, if we are not going to the find it at that point of the times, result equal to result k equal to assign -1, and after that k plus plus. Okay, this one, and at the end we are going to the return result and see it. Let's submit and see. Okay, all the test cases is done, and now let's talk about the time. Let's talk about the time complexity of the its. Okay, here it is a loop, so the here the time complexity is n, and inside the loop there is another loop. See, for the one element we are going to the traverse it the n number of the element until the find out. Many times it happened that we have not go through the n times, but in the brute force we are for the one element we are going to the search it the number of the range. At the end, the time complexity uh, time complexity become big big O n square n square. That is the not optimized way. For the optimization we are going to the use it the stack, and reduce the time complexity of the it. That is also